Hello, hello everyone. Am I visible and audible?
Yes, sir.
All right. Okay. Let's start then. So before starting, quick introductions as always. So this is this course is an NPTEL course. Its name is Basic Electrical Circuits, right? So this time it is being taken by uh, Dr. Gajendra. He's a faculty member in electrical engineering at IIT Hyderabad. So myself, I am Mayank Anupam, and I hold these tutorial sessions. In these sessions, you are supposed to ask your doubts. I will be helping. I will solving some problems, and which will be relevant to the to for solving the assignments that you will be getting in this course. So I am a, you can call me a tutor for this course, and I am a PhD EMRF scholar, and I am currently pursuing a PhD at IIT Kanpur. Fine. So these were the introductions. So all right. So let's start without any further ado. So how was the session on this Friday? That is yesterday. Did you attend?
No, sir.
Okay. So as I told, okay,
Yes, sir.
someone has raised your hand. So please, you can ask your question whatever you have. Yeah, Shivam, you have a question? Shivam, you have a question? You have raised your hand. All right. Okay. Okay. All right. So someone has posted me when someone asked me to share the link for the YouTube for the lectures basically. So the thing is that I guess the sessions are recorded and we post the links on a spreadsheet on a Google spreadsheet and and the link to that spreadsheet will be shared with you. I guess it should be shared with you in the NPTEL forum wherever you have applied or in the app whatever way you are doing taking this course you can clearly see there. Or okay, so for sharing that, I
Sir,
can share that, not a problem. But, okay,
sir, in
so
spreadsheet there are there are have some questions, but there is no answer.
oh yeah, I have posted. Yeah, correct. There are some questions which have no answers. That is true. I have deliberately done that in order for you to solve those questions. I have deliberately done that. All the questions I have not solved. I have left some questions hanging there for you to solve. Is that fine?
Okay, sir. Even check.
Huh?
Okay, sir.
Yeah. All right. Okay, so 1 second, I will be sharing the link here also. You can.
Yeah, it's working.
It's working, right? All right.
Yeah.
So yeah. So I guess that solves that problem, right? All right. So okay. So let's start now. Fine. And is my screen visibility better now? I have changed the changed it into landscape mode. Is it
Yes,
fine
sir.
now? Is it bigger?
Yes. Yes, sir.
Yeah. All right. So let's start. So those people who joined the session yesterday, where you it means this the session on Fridays, as I told earlier also in the very first session that I took, the sessions on Friday will be there to solve the questions in the assignment that are being uploaded right now. Basically, in this course, whatever assignments will be there, those will be discussed on Fridays. I will be discussing some questions which will help you in attempting those assignments. But those assignments, after the deadline is over, they will be solved in the Friday sessions. Okay. So please make sure that you attend both today's and Friday's sessions. Okay. Is it clear?
Okay, sir.
Yeah. So those people who joined was were you able to were your doubts cleared? The assignment, was it solved properly?
Sir, can you told about week 3 assignment?
No, no. I am talking about week one and week two assignments. So those people who joined yesterday's session, the Friday session are supposed to be uh, Friday session are supposed to handle all the doubts related to the assignments that are being taken this year. Okay, in this particular course. So I guess in yesterday's session, the person or my colleague who is also a PR scholar, so he might have solved the assignment problems which were already whose deadline have passed. I mean, the assignment one and two, they might have been solved in yesterday's session. So that is what I'm asking. Was it were you satisfied with that, or do you need some more help?
Sir, can you solve the week one first question because I have when it is solved, I have not in the class.
No, no, that's okay. That's fine. You can always go through the YouTube link. YouTube, it will be uploaded on YouTube. Okay. My colleague, he must have uploaded it on YouTube channel, on his YouTube channel, whatever the link to which must have been shared to you. Okay. So there you can find the link to that particular tutorial, to yesterday's tutorial, and there you can see clearly. Okay, not a problem. So if even if you miss something, not to worry. We understand that people do this course in online mode, and people have different. I mean, people can have different engagements at different point of time. So that is why we upload these sessions, so that even if you miss, you can go back and see it later, watch it later. Okay. So if you missed, all right. So whatever questions are remaining to solve in yesterday, whatever questions weren't solved yesterday, they will be solved definitely in the next tutorial. Okay. Because yesterday two assignments were to be solved, right? Week one and week two both. That is why it was a time crunch. So that is why it would have been problematic for him also. Don't worry. Next time onwards, it will be completed. Okay.
Sir, I
Yeah.
have I have a small doubt.
Yeah. Go on.
In week 3 assignment, I have shown the first question was first question options was not eh, answer is not in I, answer is not in the options.
Is it? Are you sure?
Answer
Please
was
check it clearly, because
answer,
it should be
yes,
there.
answer is 1 ampere, but there has no none given 1 ampere.
Are you sure?
I
Are you very particularly sure about your answer? Because these answers are not. These answers are carefully checked. Okay, they are reviewed multiple times before uploading. So please check whether you are doing the right thing or not. Most probably, if the answer is not matching, then most probably it's your fault. If in the scenario, in a case where the answer is not there in the basically in the option, or the options that are given to you are all wrong. In that scenario, don't worry. They will know this, and they will definitely give you grace mark also. Okay, don't worry about it.
okay, sir.
Hmm. By the way, these things that you whatever these kind of doubts related to are related to administration of the course, so you can definitely ask these questions on the forum. Okay, the so we are not supposed to handle these things. Okay, but if you ask on the forum, there are some TAs or teaching assistants which are required to look basically help you out in all these issues. Okay, they will definitely reply, and if there is any problem with the options, they will definitely check at their end and correct if needed. Okay, fine. So let's start
Okay.
because it's already 15 minutes. So before that, let's see what something. Okay, some questions have been left in week 2. Okay, these are not required. Okay, so first question first. So tell me, the question is this: the current I of t in a 50 nano and 50 millihenry inductor is shown in the figure below. Okay, now you are asked, yeah. So now you are asked the energy and the power stored by inductor at t is equal to 2.5 millisecond is given by what? Basically, what is the energy stored and the power stored by the inductor? So what do you think? So the question is this: you have an inductor, and then in an inductor. So this is, let's say, an inductor, and the current I of t is this way. Correct? Okay. So current I of t is given here. The graph of current of I of t. Now, you are told, you are asked, what is the power energy? What is the energy and the power stored by the inductor at 2.5 milliseconds? Tell me, what should I do? What do you think should I do? So what is the energy stored by the inductor? If it is carrying a current I,
Half Li
Half
square.
Li square.
yes, all right. So energy stored by an inductor carrying a current I is half L into I square, right? So what is the energy here? So what is the current at t is equal to 2.5 millisecond? What is the current at t is equal to 2.5 milliseconds?
4 amperes.
Yeah, so t is equal to 2.5 is somewhere here, right? At that time you can clearly see it is around 4. No, not around, but exactly 4, right? 4 amperes. So I at 2.5 milliseconds, excuse me, sorry, yeah, it is 4 milli, so sorry, 4 amperes. Okay, what is the energy in that case? Energy is half into inductance is 50 milli, right? 50 millihenry into 4 square, correct, which is equal to how much? How much is it?
400 milliwatt.
1 milli, how much?
What?
What did you say? 400 milliwatt?
W.
Did you say 4, did you say 400 milliwatt?
Yes, sir.
Yes, yes.
No, it is energy, right? The unit of energy is joules,
In
Okay, sir.
isn't it?
Okay, sir.
Yeah, it is 400 millijoules. So now tell me, what is the power stored by the inductor?
Power stored energy divided by time.
What is the power stored by the inductor? Yeah, so what is power?
Energy per unit time.
What is energy per unit time? It should mean that
Work
power is
done per unit
basically
time.
when energy is being dissipated or energy is changing, right? So power is basically energy changing per unit time, isn't it?
Okay, sir.
That is what is power, right? Either it should be consuming energy or it should be spitting out energy. In that case, you can define power, right? Power is what? Power is energy. Not power is not just energy per unit time. It is energy dissipated or energy delivered per unit time. Okay.
Okay, sir.
Yeah.
Okay, sir.
So in that case, what do you think power should be here? What is the power in the inductor?
160.
No, no. Again. So what does inductor dissipate any power?
So in this case, it seems that it is storing power.
It is storing power, true, but at this point of time,
Yes,
at
sir.
2.5 milliseconds,
Yes, sir.
it is full. It is charged. Okay, and it is
Okay.
keeping that charge in this. Okay, so see
Okay,
here
sir.
it is charging. You are definitely true. It is charging here. Okay, it is being charged, and because of that, there is some energy which is being delivered to
Stored.
the inductor, but after that, right from this point, it keeps that energy with itself, right? This
Okay,
energy is
sir.
not changing. So at this point of time, at this point of time, what is
Mm.
the energy, what is the power that it is that is being delivered to it, or what is the power that is being dissipated in it
None.
at this point of time? Huh?
Zero, sir.
None. Zero, sir.
Yes, it is zero, right? Because you see, in steady state, the inductor does not burn any power, right? It because energy it does not dissipate any energy. That is why the power dissipated by an inductor in steady state has to be zero, right?
Yes, sir.
So
Yes, yes.
you can clearly understand that this is the steady state itself, right? After this time, after 1 millisecond, going in this direction every time is steady state, right? Because everything is settled, nothing is changing with time, correct?
Okay, sir.
So definitely power is not being dissipated here, correct? So that is why power, so power is what? Zero, as inductor doesn't dissipate any power. All right. So any doubt in this question?
Sir,
Yeah.
hello, sir.
Yeah.
Sir,
Yeah. Go
can we
on.
write power P is equals to V into I, and in place of V, shall we put L into di by dt? In that case, di by dt is zero, so power also
Yes.
becomes zero,
Yes.
right?
Yes.
That is
Yes.
also
Exactly.
equation
Yes.
point.
Yes. Yes. Exactly. Exactly. So that is why
Uh,
I said, na, in the steady state,
yes,
when the current is basically when the inductor is fully charged, that means that it means that the current is not changing, right, in the inductor.
yes, sir.
That is why
Mm,
di by dt has to be zero. That is why it is zero. Yes, you are right.
yes, sir.
So so everyone what your colleague is saying is that so the power is basically V times I, right? So let's say this is V. So space problem. Let's call this as V of t. So power is what? V into I, right? Or rather V of t into I of t, correct?
Yes,
Now
sir.
V of t is what? LdI by dt, and I of t is I of t. Okay. Now you see di by dt is 0 after this point, right? In this direction
Yes,
it
sir.
is 0. That is why
Yes, sir.
the voltage is 0, which means power has to be 0, right? Fine?
Yes, sir.
Yeah. Moving on to the next question. Yeah. Determine the total power absorbed by all the elements of the network shown below. Yeah. Tell me. What should be the what? How should I do it? Now that I have solved one question, now I expect you to solve it for me. This question.
We should apply passive sign convention, sir.
Definitely yes. So tell me passive sign convention for all the elements.
Uh, for 50 volts battery,
Hmm?
as per passive sign convention, current direction should be opposite to that 5 ampere.
Okay, so for let's take this 50 volt.
Yes,
This
sir.
is minus, this is plus, right?
Yes, sir. Yes, sir.
And the current that I should be assuming here should be what? In this direction, right?
Yes, sir.
Right? So this
Yes,
is
sir.
for 50 volt.
Hmm.
So, okay, current in this case is minus 5 ampere, right?
Yes, sir.
Correct? Okay. Coming to this, what should be the, what should I do?
Uh,
Sir, we could use the relation power is equal to I square R.
No, no, that is
can
fine.
we follow same current
First,
direction, sir? In
yeah, yeah,
whichever.
definitely. Yes.
Uh,
So let's take this direction, okay? Let's take this as my plus and this as minus, okay?
hmm. Hmm.
And in this case, I do not need to change the current direction, right? It can be here, it can be this direction only. And this is 5 amperes, correct?
Yes, sir. Yes, sir.
Fine. Now
Hmm.
tell me about this 80 volts.
By
This
okay,
is
at
plus, this
80
is
volts.
minus,
Yes, sir.
and 7 ampere is correct direction, right? This is
Yes,
7
sir.
ampere
Correct.
itself.
Hmm.
Fine. Now about with the of this 20 volts, tell me what should be the
By
direction?
by KCL, sir.
Huh?
Current by using KCL.
Huh?
Current flowing through 20 volts battery should be 2 ampere.
Correct. In which direction?
As per passive sign convention, current direction should be downwards.
It should be downwards,
Uh,
yes. So is it
but
downwards 2
actual current
ampere you are
direction is
saying?
opposite, sir.
Ah, right. So actual current direction is what? It is actually
Opposite towards
2
upside.
amperes in this direction. But for passive sign convention, I'll be assuming this to be minus 2 amperes, right?
Yes, sir.
Correct. So everyone is following me, right?
Yes, sir.
Fine. Now what about this 4 amperes? Sorry,
If you
4
take upper
ohms. 4 ohms,
4
yes.
ohms, if you take upper terminal as positive and lower terminal as negative,
Okay.
current direction should be towards downside.
Again minus 2 ampere, right?
Yes, sir.
Fine.
Yes, sir.
Okay.
Now we should
Now tell me.
calculate power of each
Ah,
element.
yes, yes. Very good, very good, very good.
Hmm.
Tell me. So what is the power in this?
Power at a 50 volts battery is 50 volts
50 volt
into
is 50 volts into
50 minus 5 ampere.
50 into minus 5
Min-
amperes, right?
Minus 250 watt.
50 volts into minus 5 amperes. So this is minus 250 watts.
Yes, sir.
Okay, so this is sorted. What about 10 ampere, 10 ohms?
I square R we can apply.
I square R you can apply, yes.
5 square 25. 25 into 10, 250.
Okay, so it be positive or negative, the resistor power?
Positive, sir.
Positive,
Why?
sir.
Why do you say that with
As
so
per
much
positive sign
confidence?
It is
convention.
consuming power, sir.
Okay, so
As
first
per
thing,
passive sign.
no. First thing, as per passive sign convention,
Yes,
yeah,
sir.
you are also correct. So always remember that in a resistor can never deliver power, right? It always has to consume power. It will always dissipate power, right?
Hmm.
And as per the passive sign convention, the passive sign convention is basically it will be positive. The power will be positive in passive sign convention when it is what dissipated
Or observe.
or what?
Absorbing power.
Yes, yes. When something is absorbing power, as per the passive sign convention, the power will always come out to be positive, right? So in this case also, this resistor, it always consumes power. So that is why, as per the passive sign convention, also you can see that this 5 ampere when it passes through 10 ohms, the voltage in the direction that I have shown here, it will be how much? 50, right?
Yes, sir.
Correct. So clearly it is V into I is positive, right? So yes, you can always use I square R or V into I, whatever suits you. So yeah, tell me what will be the power here?
250 watt
Again,
plus 250 watt.
Yes,
yes,
sir.
fine. This is also 250 watts.
Yes, sir.
Okay. Sorry for my drawing. Fine. Now let's take this guy out of the picture. So what is this? What is the power here?
7 ampere into 80 volts.
7 ampere into 80 volts, which is
560 watt.
560.
correct. What about this? 20 volts
20,
battery.
20 volts into minus 2 amperes.
20 volts into minus 2
Minus
amperes,
2
which
amperes.
is minus
Minus
40
40 watt.
watt. Very good. What about this?
I square R we can apply. Minus 2
Yes, you
whole
can
square
apply
into R.
minus 2 square into 4 ohms, right?
16 watt.
16 watts, correct?
Yes,
Tell me
sir.
what is the total power absorbed? That was a question, right? Absorbed.
Yes,
Yeah,
sir.
total power absorbed by all the elements. Tell me, summation, right, of individual power, correct? Right now?
Yes, sir.
Yeah. So is it minus 250 plus
250.
250 minus or plus 560, right? Minus
Yes, sir.
40 plus 16.
16.
This and this cancel each other. 40 and 16 will be what? How much? 24, right?
Yes, sir.
Right? Or rather in another way, 560 minus 40 is 520. 520 plus 16 is 536.
536.
Right?
Sir,
Yes.
I have
Yes.
a doubt here, sir.
Yes. Go on.
Sir, as per question, they're asking total power observed by the elements.
Yes.
So, why we considered that minus 250 and minus 40, sir? Those elements are delivering elements, no? Not observing.
No, no. I mean, net total power absorbed by the network. That is the question, right? That is how I interpret it.
So, as per question, the total power observed by all elements means which are
Uh-huh.
observing.
No, no, that is
Means,
again the way you interpreted it. I am saying that the way I interpret this question is what is the total power absorbed by all the elements in the network? To me, it means that what is the net total power if this network is standing alone. Okay, basically you do not know anything about this network. You just have three terminals. Okay, coming out. So this is one terminal. This is one terminal, and this is another terminal, and you do not know anything about it. When you connect these three terminals to whatever you want, whatever sources you want, and you saw that okay, so this has 7 amperes current here, this has 5 amperes, this has again 2 amperes in this direction, and you saw, and when you put a power meter there, so you will what will you see? You will see that the net power, you will calculate the net power absorbed, right? You will not calculate the power that is basically the power will be summation of absorption power, whatever power is absorbed, whatever power is delivered, right? So that is why it is 536 watt. You are correct. I mean,
okay,
this is just interpretation.
okay,
Okay,
sir. Okay,
don't
okay,
worry
sir.
about it. Don't go into that the wordings of that. Okay, so as long as you understand what you are doing, it's fine. So the whatever. So you were the one who walked me right through it, right? You told me to use passive sign convention here, right?
Okay, yes, sir.
So I'm
Yes,
guessing
sir.
you understood everything, so it's fine. Don't go into the grammar of the question. Okay.
Okay, sir. Okay, sir.
Yeah. Yeah, fine.
Thank you, sir.
Yes, yes. All right. So this I don't think anyone has trouble. So you only solved it. Let me move forward. Problem 3. Okay. Yeah, this is a interesting question. So this kind of questions are asked always in interviews and placements. So they will ask this kind of questions, even GATE exams also. The minimum number of mesh equations required to analyze the circuit given below. Tell me, how many will you need here? The minimum number of mesh equations. Yes.
Sir, I think there is row and column, and row one and column one, row two and column two. Then it is a whole it is whole circuit. Then it will be compared to C3 or R.
One second, one second. I didn't. Where is row 1 and column 1? Oh, R1 and R2 you are saying. This is resistor. There is no rows and columns. This is resistor. This is capacitor.
Oh, yes, sir. Yes, sir.
Yeah,
I have
yeah,
my mistake.
yeah. So tell me, how many mesh equations? What is the minimum number of mesh equations required to solve this particular circuit?
Sir, 4, sir.
How did you come with that number?
Based
Sir,
on number of
R1
meshes,
and
sir.
yes,
Yeah,
yes.
one second. Yeah, R1 is what? What were you saying?
There is an R1, R2, and R5 and R6. So there have been four instances which can we want to do it.
5 meshes are
No good thing about it. So the person who said 4, I am interested in knowing what is your. How did you come up with that number?
It is counted based on number of meshes, sir. First, I counted number of meshes in the circuit. So
Okay,
I got
so
4 meshes.
tell me how did you count? I will also please help me count
Sir,
basically.
yes, sir. Voltage source Vs, resistor R4, capacitor
Okay,
C1, R3 is
okay,
forming
okay. So this is one mesh.
one mesh, sir. And the second mesh, I consider this C2,
C2,
C2, R3, R5, sir.
C2, R3, R5 is another mesh. Yes, it is
That is
another
the
mesh.
second
Yes,
mesh. Hmm.
yes.
Third mesh is R1, R2, C1, C2, sir.
R1, R2, C1, C2. Yes, it is another mesh. Yes.
Yes, sir. Last mesh, fourth mesh is R2, R5, and C3.
Okay,
Actually, I
so
shifted that C3 lower node to
R1,
towards
R3.
R5.
Okay, one second. Come again. Last mesh is what? Which one is the last mesh?
R R2,
R.
R5, C3.
Where is R2? R2 is this one. R5 is this one. And then
C3, sir.
C3. Okay.
C3, sir.
All right. So, but there are more meshes, right? How did you say that this is the minimum number required? I mean, I can definitely make more number of meshes, don't you think?
Sir,
Yes. Yes, yes. These are the four meshes I understood, and I understand that. But I can make more meshes at this point. So what? How did you know that you require only four meshes? I mean,
actually, the
how?
question is minimum number of
Yes,
meshes
yes,
they asked.
correct. So how do you know this is the minimum number? Why not one more mesh? I mean, definitely there is another mesh here, right?
Sir,
This.
while forming these 4 mesh equations, we will include all the terminal
Sir,
characteristics of all the elements. So we don't need any more equations. So
Yes,
this could be set as minimum required.
yes,
sir,
yes,
can I
correct.
say that
Yeah, yeah. Go on. You say.
whatever the previous mesh you have written, it is erased now. One more
Okay.
mesh you are showing left side, na, sir.
Yeah, this is basically R1. This is R4, R1, C3, and VS.
Hmm.
Huh.
So in red color one and in purple color one, both we
Huh.
cannot consider, sir. At a time we should consider any one only.
Why? Why?
Either we
How?
should
How
take
come? How
R2,
come?
R5, R3,
No. Why not?
or
Why?
pure path.
Why do you say that? Yeah. Why do you
Actually,
say that?
it is like a duplicating, sir.
No. Is it? It is not. No. This is one mesh. This is another mesh. They are perfectly fine.
Okay.
So the answer that another guy gave is the correct answer. So the thing is that you all the minimum number of meshes. So you can draw a lot of meshes, right? Given a network, you can draw a lot of meshes, lot of loops you can draw, right? And you know, and you remember that relation, right? How many loops can you draw given a circuit with n nodes and b branches?
B
How many
minus L
how many
plus
loops can you draw?
B minus N plus 1.
I think five
Yes,
loops.
correct. B minus n plus 1 you can draw, right?
Yes, sir.
You
Yeah.
can draw this many number of loops given a circuit. So in this question you can find out how many loops you can draw. But tell me, how many of them will be independent? You can definitely write a lot of loops. Okay, you can definitely write a lot of loop equations. But how many of these will be independent? By independence, I mean you cannot get one by linear combination of the others. How many of these are of those kind of that kind? So in this case, there are only four. Okay, and why is that? You see, the reasoning that one guy gave is that so you always need. So basically, while writing the mesh equations or while forming the meshes, you just have to see that you just have to ensure that you go through all the elements. Okay, hello, are you there?
Yes, sir. Yes, sir.
Yeah.
Yes, sir. Yes, sir.
So you just have to ensure that you go through all the elements in the mesh. You take consider all the elements, and you should not. Okay. Yeah, Swarna, you have a doubt. You have raised your hand.
They're not getting the theory of independent measures.
Okay. No, no. So the thing is that you remember independent KCL equations. That was I think I mentioned in the class in the lectures. Independent KCL equations were mentioned in the class, right?
Sir, in this question, I'm not getting independent measures.
Okay. Uh, so no. Okay. Let me do this. Uh, so tell me this. Let's say this is okay. I erased one, right? Yeah. So in all these four meshes that I have drawn here, okay. Can you represent any of the mesh equation in terms of linear combination of other mesh equations? I mean, you will write a equation here, right? So let's call this. So while writing mesh equations, you always assign a current, right? Mesh current. Let's call this I1, I2. Let's call this I3. Let's call this I4. Okay. So you always do that. Now tell me. So I3 is basically this red one, I3, and I4 is this black one. So tell me, while writing these equations, you will write KVL equations for all the meshes, right? That is how you solve uh, using meshes. Am I right? So are you there, Swarna?
Yes, sir.
Yeah. So are you there with me? I mean, till this point, everything is clear, right? You need to
Yes, sir.
assign some currents: I1, I2, I3, and I4. Correct? Fine.
Yes, sir.
Now, when you do that, yeah. So when you do that, now when you write all the equations, can you derive any of the so you will get equation number 1, equation number 2, equation 3, equation 4. So any equation, can you get any equation in all these three, in all these four, as a linear combination of uh, the other three? Is that possible? I mean, can you get equation 1 by simply, equation 1, can you represent it in this manner? some a times equation 2 plus some b times equation 3 plus some c times equation 4. Can you do that? Can you get it in this manner? So remember KCL equations that was taught to you in the class. You remember that
Yes.
for solving an n node circuit, you required only n minus 1 KCL equations, correct?
Yes, sir.
Why not n KCL equations? Why only n minus 1 were sufficient? What was the reason given to you?
So clearly,
Okay,
I don't know the
okay,
reason.
okay, fine. So, let's say this is one element, this is another element. Okay, this is another element. These are all the elements. So this is node 1, 2, 3, and this is 4. Okay. Now you remember that you can write KCL at all the nodes. This is one node, this is one node, this is one node, this is also another node. But you know that you only require 3 KCL nodes to 3 KCL equations for this question, correct? For this particular circuit, right?
Yes, sir.
Yeah. So what is why don't you require the fourth one also? So the reason was that
Grounded.
the yeah, basically it's not grounded. I mean, the thing is that this all the currents, if you draw a surface here, right, between
Yes, sir.
the fourth node and the other three nodes, you can clearly see that all the currents that are going to be leaving this
One
here
more only.
are going to be coming out of here only, correct?
Yes, sir.
Right. So basically the currents are all related. That is what I'm saying. So one equation is
Okay.
redundant in that sense, correct? One node is redundant,
Okay.
right? So you require
Okay, sir.
only n minus 1 KCL
See.
equation. And
Okay.
even if you write n KCL equations here, if you write all the 4 KCL equations here, you will realize that if you add the KCL equations of 1, 2 and 3 node, you will
Okay.
arrive at the KCL for 4th node.
Okay, sir.
Okay, so that is what is meant by independence. I mean, so all the 4, if you only the 3 KCL equations are independent. The 4th one is a linear combination of all the 3. Okay, so
Okay.
similarly
Okay.
in this case also you see that when you start writing the KVL equations, yes, you will see that after writing 4 equations, you will see if if you go any higher than this, if you take any higher number of mesh, let's call it, let's say you also take this mesh. Okay, that the one that I showed earlier. Let's say you also take this mesh. In that case, what you will see is that and you will get 5 different KVL equations. You will see that when you add all the 5, oh, no, sorry, when you add any 4 of these, you will get the other 5, other 5th one. Okay,
Okay, sir.
yeah, so these are not basically these are not independent, they are dependent on each other. Fine.
Yes, sir.
So a reason for this is very simple. Why exactly 4 are said to be, why only 4 number is sufficient here? So reason can be very simple here. So you see, the minimum number of mesh equations required to analyze the circuit is simply basically it's basically age old linear algebra. So if you have n number of n variables, how many equations you will need in order to solve that circuit, in order to solve that equation, in order to solve for n variables, how many, if you have n unknowns in a equation, in basically a set of equations, if you have n unknowns, so let's say you have n variables, okay, so how many equations you need to uh, to find these n variables?
N equations.
N equations, right? N independent equations you want, correct? You need n independent
Yes.
equations, and if you have n independent equation, you can definitely solve for all the n variables, right? This is linear algebra, correct?
Yes, sir.
Yes, fine. So now tell me how many unknowns are there in this circuit. So what is the purpose of solving a circuit? You want to find the current through it, you want to find the voltage across it, right? Across all the elements you want to find the voltage and the current flowing through all the elements. That is the purpose of solving a circuit, right? Is that fine? So
Yes, sir.
Sir.
now tell
Five,
me how many unknowns are there in this question. How many
five,
unknowns are there? Huh?
five unknowns.
How do you come with that number? 5 unknowns?
Four, four currents. I1, I2, I3, and I4, and
Okay,
one
one
voltage
second,
of
one second.
VS.
Let's erase this. What is the purpose of solving? It is to know all the currents, right? Not just the current in the loops, but all the currents,
Okay,
right?
okay, okay. Sorry, sir. Okay.
So this is the currents. These are all the currents, right? Right? So now tell me how many unknowns are there, and how many. Tell me how many unknowns are there for a B branch. For a circuit with B branches, there are 2 B unknowns, right? Is that fine? You remember this, right? There is too much silence. You remember this? This was just covered in the lectures. For a circuit with B branches, you have 2 B unknowns, right? You have B voltages and you have B currents, correct? Is that fine?
Yes, sir.
Yeah. So don't be so silent. I mean, this is already covered in the lectures. I'm assuming that you know these things. Okay. Okay. So there are B voltages and B currents. So exactly there are B voltages here also. All the elements, they represent a branch, right? Each element in this particular circuit, it represents a branch. So how many branches do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 branches we have, right? So we need 18. There are a total of 18 unknowns. Okay.
Okay, sir.
Yes. Now tell me. Yeah. Now tell me. How many? 1 second. Now tell me. What is the? Okay. So how many nodes are there in the circuit? How many nodes? How many nodes are there in the circuit?
5.
8
How did you come with
nodes.
that number again? So this is a node, right? This is a node. This is a node. This is a node. This is a node, and this is a node. How many are these?
1, 2, 3, 4, 6.
6 nodes are there, right? So you have how many nodes? 6 nodes. How many total branches you have? How many did we calculate? 1, 2, 3, 4, 5, 6, 7, 8. Oh,
Okay.
9. We have 9 branches, right?
Okay, sir.
So 9 branches. Cool. You have 6 nodes, 9 branches.
Okay, sir.
So what is this? What is B minus n plus 1? How many loops can you form?
4.
4 loops you can form, right? Is that
Yes,
fine?
sir.
So from here you see that clearly you can four loops, right? You
Okay,
can
sir.
form 4 loops here. 4 independent loops you can form here. Is that fine?
Yes,
Yes,
sir.
sir.
Yeah. So this is fine, right? This way of explaining is fine. 4 loops you can find here. You can clearly find 4 loops here. Fine.
Yes, sir.
Okay. Now tell me another. There is also another way to look at this problem. So as I already told you, as we already saw, there are 6 nodes in this circuit. Okay. But tell me, if you are given this particular circuit, among the 6 nodes, you know that only 5 nodes are required to solve this circuit, right? Because one node will be simply, you can assume it to be reference, right? Hello?
Yes, sir.
Yeah. So one node you have to assume that it is a reference. Okay. Now you have 5 nodes here. So ideally, you would have required 5 KCL equations, right? Fine. You would have required 5 KCL equations here, ideally.
Yes, sir.
But now, let me ask you this: what is the purpose of using KCL equations? KCL equations are used to find the KCL equations are basically the
Node
basically
voltages.
voltages, right? Basically used for finding voltages, right?
Yes, sir.
Yes. Now tell me the voltage at this point.
Thank you.
It is what?
Sir, VS.
VS.
Vs. It is Vs here, right? It is Vs here. So
Yes.
you now need only 4. You now only have 4 variables, right? Let's call this V1, V2, V3, and this is V4. So now you have only 4 variables here: V1, V2, V3, and V4. Isn't it?
Okay, sir.
Because the other 2 variables, this node and this node you have assigned to be a reference is equal to 0 volts, and
Okay, sir.
this node, you know the value of voltage at this node, right? This is
Yes,
Vs
sir.
itself. So you have only 4 variables here. Now tell me how many independent equations you need to solve these 4 variables, for 4 variable to find these 4 variables. How many independent equations you need to find these 4 variables?
4.
Yes, you need only 4 independent equations, right? So from here also you can see that. So since number of independent variables, voltages, equal to 4, so minimum number of equations is equal to 4. Fine. So always remember that whatever the circuit, this KVL and KCL are just counterparts of each other. Okay, I mean they are just dual of each other. With anyone you can solve, uh, not with anyone, but you need both of these. But they are a lot of times you will be using both of these, but you will not even know that you are using both of these. Okay, so the thing is that with any basically KCL and KVL, you can use any of these two. Okay, along with the branch relationship, branch IV relationships. Okay, you understand what I am saying? So you will
Yes, sir.
need either KVL or KCL, and along with these, along with this, you also need branch IV relationships. Branch IV relationship, by that I mean, for resistor IV relationship is what? I is equal, sorry, V is equal to I into R, right? These kind of relations you need for all the branches, and you need KCL or KVL equations, and then you can solve the circuits. Okay, so the minimum number of equations that you need to write in each case will always be equal to the number of number of variables that you have in the circuit, number of independent variables you have in the circuit. Because the ultimate aim of solving any writing any equations here is to simply find the variables, right? Voltages and currents. So if you know the voltages at all the nodes in the circuit, you can definitely find the currents, right, by simply using IV relationship for the branches. Okay, so that is what I said when I that is why what I meant when I said that in this question you can you can see the number of independent voltages, and then you can simply calculate how many equations you need to write. But if that explanation doesn't satisfy, you can always go through the systematic approach for this question, which is this one. Okay, you find what how many number of nodes are there, how many branches are there, and then you simply write b minus n plus 1. This is the number of loops that you require. Okay.
Okay, sir.
Yeah. Okay, fine. So let's move forward. So the approach that I said now in this question, that this approach in which I found the number of independent nodes, this approach may be useful to you when you I mean, with some experience you will come to appreciate these kind of approach, because in exams you might forget this formulas b minus n plus 1 and all those things. You might forget these things. So, or in interviews also, so you might these things might come in handy. Okay, fine. The current I of t shown in the figure is applied to a 4 microfarad capacitor having initial voltage equal to 2 volts. If W1 is the energy stored in the capacitor over interval 0 to 2 and W2 is the energy over the interval 2 to 3, then, not then, tell me what is W1 and W2. So the capacitance is, let's say this is the capacitor, okay, let's call this to be voltage V, okay, or only V, this is the capacitance, okay. So what is the energy stored in the capacitor if it has a voltage V across it?
Half CV square.
Half into C into V square. Okay, fine. So this is the energy EC. Okay, okay, fine. So yeah, now tell me, it is given that the capacitor had an initial voltage equal to 2 volts. So there was some V initial on this capacitor. There was some initial voltage on this capacitor. Okay. V initial was what? Or let's call it V of 0 was what?
2
2
volt.
volts. Okay. Now you see that at 0 time, at time is equal to t is equal to 0, a current is flowing into the capacitor, right? Basically there is a current I of t which is flowing in this direction on the capacitor. So what will it do? This current that is flowing in the capacitor, what will it do?
Increase the voltage, sir.
It will increase the voltage, or in other words, it will simply charge the capacitor, right? It will start
Yes, sir.
charging the capacitor.
Yes.
Okay, so tell me what how will the capacitor charge look like? So in interval 0 to 2, that is one interval, so this is one interval, and this is another interval. Okay, so tell me, at the end of 2 milliseconds, what will be the energy stored in the capacitor? How will you find it out? Yeah, go on, tell me. What will be the energy stored in the capacitor at the end of 2 milliseconds? How will you find it out?
So energy stored will be V is equal to C integration I dt plus V0.
First, we have to find out. First, you have to find out what is the voltage, right? At the end of 2 milliseconds. Correct?
Yes, sir.
Yes. So voltage at 2 milliseconds is what you will have to. So basically, you will need this, right? V. So you know that the current I of t in a capacitor is equal to C times dV by dt, right? So from here you know that the dV of t is equal to C integral C integral I of t,
IDT.
right? Or it is not C, it is 1 over C. Integral I of t dt, correct? So
Okay,
now
sir.
you have to apply the limits. So time t is equal to 0 to what? 2 millisecond you need, right? 2
Yes, sir.
milliseconds. And at t is equal to 0, what was the voltage across the
2
capacitors?
volt.
2 volts. And this I don't know, right? This I don't know. So let's call it V, or let's call it V2 milli, right? Tell me, so
Okay,
what
sir.
will it be? So V2 milli minus 2 volts will be 1 over
1 by
C multiplied by.
I
So
square
what is
by
I
2.
of t here? What is I of t here?
It is a ramp function
It is a ramp function with slope
with slope 1.
1 what? What is 1?
Milliamp.
What is 1? What is 1? It is
Uh,
1 milliamp per second, right? Per millisecond, or 1 ampere per second, right?
okay, sir.
So always take care of the units, okay? Yeah. So the
Okay, sir.
slope is 1 amps per second, right? So what will it be? So here it will be 1 amps per second into t, right? Correct. What is the equation of this straight line? Slope multiplied by the x-axis function, right?
Yes, sir.
X-axis
Independent
variable.
variable.
Yes. So it will be 1 into t dt, right? 0
Okay,
to
sir.
2 milliseconds. What will it be? V2 milli minus V 2 volts is equal to 1 over C into t square by 2, and the limits will be 0 to 2 milliseconds. So what will it be? V2 milli will be how much? 2 volts plus 4 milliseconds square, 4 seconds. Yeah, let's convert this into seconds only. 10 to the power minus 6 divided by 2. Is that fine? Is this fine? Is this fine?
Okay, sir.
So you also solve at your end, so that if I make a mistake, you correct me immediately. Yeah, so what is the value of C? How much was C? It's a 4
4
microfarad capacitor,
microfarad.
right? So let's replace. So how much will it be? 2 volts plus 4 into 10 to the power minus 6 divided by 2 into 1 over 4 into 10 to the power minus 6, right? So this and this cancel each other. Overall it will be V2 milli will be how much? 2 plus 0.5, which will be 2.5 volts, right? So at the end of at t is equal to 2.52 millisecond, the voltage that will be that will come across the capacitor will be 2.5 volts, right?
Okay, sir.
Okay, so tell me, what is the energy stored in the capacitor at t is equal to 2 millisecond? So what is energy at 2 milliseconds? Half into
4 into
C
10 to
into
the power
V
minus.
square, which is half into C is what, 4 microfarad into
Yes, sir.
V square, which is 2.5 the whole square. This is equal to how much? It is simply 2 into 10 to the power minus 6 into 6.25, right? Right?
Yes, sir.
So it is
12,
how much is it?
12.5
12.5
microjoule.
microjoules, yes. And the question that is asked to you is, W1 is the energy stored in the capacitor over time interval 0 to 2. So tell me, how much energy is stored in the capacitor in this interval from 0 to 2 milliseconds?
12.2 joule. Microjoule.
How did you come with that? 12.2?
Sir, we have calculated this.
No, we have this is 12.5 microjoules, right?
This is the total energy, sir.
Yes, this is your total energy. Yes. So you have to
Then
subtract the initial energy, right?
okay, sir.
Yeah, so correct. So you have to subtract the initial energy. So what was E of 0? Half into C into V square, which is again half into 4 into 10 to the power minus 6 into 2 volts, right?
Yes, sir.
So what will it be? So 4 into 4 is 16, by 2 is 8, 8 into 12, 10 to the power minus 6 joules, which is how much? 8 microjoules, correct?
Okay, sir.
So what is the energy? Uh, energy stored in 0 to 2 milliseconds is simply E of 2.5 sorry 2 milliseconds minus E of 0, which will be 12.5 microjoules minus
8
8 microjoules, which will be 4.5 microjoules,
microjoules.
right?
Yes, sir.
Yeah. So similarly, you can also find what is the energy over the interval 2 to 3, right? So in this interval also you can find out how much energy is stored on the capacitor only in this interval. Fine. So
Okay,
that I
sir.
am not solving. You can solve it. Is easy. So anyone having any doubt in this particular question? Okay. So in that case, let's move on. So the question, we are told to find the power absorbed by 200 milli ohm resistor in the given circuit. So this is a 200 milli ohm resistor here, right? So what is the power? This is a 200 milli ohm resistor. So what is the power absorbed in this resistor? That is the question. Come on, solve it fast. Well, this should be easy now because this has been done so many times. It should be easy now. Come on, guys, solve this question. Tell me the answer. Come on, solve it. I'm not going to solve this question here because it's very easy. This basic, simple circuit analysis. What will you do here? Tell me. How will you solve this question?
So I'll use the delta star transformation, then calculate the equivalent resistance, then
Okay.
calculate the current through 200 milli ohms.
Yes.
Then it will give the power
Yes.
expression.
Yes. Yes. Correct. Correct. So that delta star transformation is not covered in this particular course. I am guessing, right? It is not covered till now.
Sir, I have
So
no
how?
idea.
Oh, so this is not covered till now. Yes. So this is not covered. But yeah. So that is a perfectly valid approach. You can always convert this into star network. Okay. The star network will look something of this kind. And like this, something like this. Okay. So from that you can definitely calculate whatever you want to find out. So there will be three terminals in the star network, right? So this will be one terminal. Okay. So this is one terminal, this is one terminal, this is one terminal. So these three terminals will be connected to the three terminals here. So this is one terminal, this is one terminal, this is one terminal. All these three terminals are connected to these three terminals. Okay, and then you can simply calculate. So this is one approach, right? But this is not covered, so I'm not going to discuss this. So what is another approach? So another very simple approach is what? Use KCL and KVL, same old, age old thing, right? KCL and KVL equations. So in this case, what will be easier, KCL or KVL? Tell me.
Sir, KCL.
Okay, so for KCL, what will you do? You have to first take these three nodes, right? This node can be assumed to be ground. Okay, so this is V1, this is V2, and this is V3, right? Am I
Yes, yes.
correct? That is fine. So you take these three nodes now. Simply write KCL equations at these three nodes, right? Right. Simply write KCL equation at all these three nodes, and you will be able to find the current, and then the power absorbed by 200 milliohm resistor is very easy, right? You simply have to find the current I here and use I square R. It will be easy to find. Correct? Okay. So let's say I want to solve this circuit in by using KVL. How will I do that? As the person who told you said that I want to solve this question using star delta transformation. So tell me, how will you solve this question by using the circuit by using KVL?
So we will have to write three mesh equations.
Yeah, tell me, what will the three mesh look like? Which three meshes will you choose?
So first mesh will include 4 ohm, and 200 milliohm and 10 volts.
This is one mesh, right?
Yes, sir.
Okay, so you will assign a mesh current with it. Let's call it I1.
Yes, sir.
So while doing that, what direction will you choose of the current flow?
I will choose clockwise direction.
Clockwise direction. So all the guys, always remember, always follow only one kind of this thing. Always go in the same direction while using KVL equations. Okay, otherwise you will get confused unnecessary. So personally, for me, I always use clockwise direction. Okay, so for me, clockwise is assumed to be for me, clockwise is the correct one. I personally prefer clockwise. You can always go other way, anti-clockwise also. Okay, but always make sure that you use the same direction in all the loops. Otherwise, it will become very messy for you. Fine. So now tell me other loop.
The second loop will include 4 ohm, 8 ohm, and 6 ohm.
4 ohm, 8 ohm, and 6 ohm, and this will be the current direction, right?
Yes, sir.
So what? Let's call it I2. And what will be the third mesh look like?
Third mesh will include 4 milliohm, 6 ohm, and 10 volt source.
This one, right?
Yes, sir.
Let's call it
I3.
I3. Tell me. Okay. Now tell me, what will be the equations for, let's call it mesh number one. Let's call it mesh number one. Let's call it mesh number two. Let's call it mesh number three. Okay. Now tell me, what
Yes,
will
sir.
be the equations for mesh one? What will be the equation for mesh one? Mesh one.
Sir, 4I1
4I1.
plus 4I1 minus I2.
Are you sure? I mean, how did you come with that?
Sir, the upper 4 ohm, in the upper 4 ohm resistor, I1
Uh-huh.
and I2 are in opposite direction, sir.
So you
So
said
they
plus
will have,
4I1. Did you say plus 4I1 minus I2?
yes, sir, I1 minus I2
Okay, fine. Okay.
plus 200 milliohm multiplied
Plus
by
200 milli ohm
minus multiplied by, sir, I1 minus I3.
I1 minus I3. Yes. And
Sir, is equal to 10 volt.
is equal to 10 volt. Right?
Yes, sir.
So, but let's say you don't want to write is equal to. So how will you write? Minus 10
Minus 10
volts,
volt.
right? Is equal to 0. So, did everyone follow this? Does anyone have any doubt in this? Okay, so no one has any doubt. So this is fine. This is correct. Similarly, what will be the equation for mesh 2? So, so okay,
Here,
let me clarify. Just okay, 1 second. Let me just clarify. So what our friend has done is that he has always chosen uh, positive. This Please see that 4i1, 4i, all these are in positive. There is always a plus sign here, right? There's always a plus sign here, correct? So what he has done is he has chosen voltage drop to be positive and voltage increment to be negative. You see, while going from here to here, we in this direction, if the current is flowing, we have a voltage drop, right, across 4 ohm. But I have for that I have taken plus 4 into I1, the voltage drop. The voltage drops in this case are considered positive and voltage increments are considered negative in writing this equation. While going in this direction again, I1 minus I2 is flowing across this 4 ohm resistor, and again the voltage that will be dropping across it will be 4 into I1 minus I2. Similarly here also the voltage will be dropping, it will be 200 milli into I1 minus I3, right? But across this 10 volts, okay, so okay, 1 second. Okay, our friend has made a mistake here. The person who told me to write this equation, what is the mistake here? Tell me.
Sir, in the
200 milli,
voltage source.
300 milliohm.
No, no, this is fine. Here it should be a plus sign, isn't it?
Yes, sir. The sign would change.
Because again, you are going from here to here, you are dropping by 10 volts, right?
Yes,
So in
sir.
writing this equation, you assume that all the voltage drops will be positive. You have considered the voltage drops to be positive, right?
Yes, sir.
Yeah. So this is the thing. Fine. Okay. So anyone has any doubt in that? Okay. Now
Sir,
tell.
but
Huh?
sir, 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 but I think the first 4 ohm is 4i1 is minus. I think because it is from the clockwise direction and it is there is nothing in the ground.
No. Why should it be? This is fine. This the equation is fine. You see, two things you have to consider. Okay, first thing you have to choose what kind of direction you follow. So I follow clockwise direction. So in this equation also we have followed, in this meshes also we have followed clockwise direction, right? This is clockwise, this is clockwise, this is also clockwise. Fine. This is one thing. The other thing that you have to choose is you have to decide on what kind of convention you want to use. So basically there are two conventions which you can follow. Either or two is fine. So if you can consider voltage drops to be positive and voltage increments to be negative, that is also fine. What I do is I consider voltage drops to be negative and voltage increments to be positive. So but in this case we have considered voltage dropping across any element, that we have considered to be positive. Is that fine? So here it is correct actually.
Yes, sir.
Ah, fine. So let's write the mesh equation for mesh number 2. What is the equation for mesh number 2? This mesh. Yes. Tell me.
Sir,
The person who,
8i2
yeah. 8i2
plus 6
plus
into
6
I2 minus I3
I2 minus I3. Yes, very good.
plus
Plus
4
uh,
into I2 minus I1
I2 minus I1
is equal to
equal
0.
is equal to 0. Yes, very good. For mesh 3, yes. What will be the equation for mesh 3?
200 milliohm
200 milliohms.
multiplied by I3 minus I1
Okay.
plus 6 multiplied by I3 minus I2 plus 6 I3 minus 10.
Minus
Yes,
10. Yes.
yes, sir.
Yes. Very good. Yeah, fine. So when you solve all these three mesh equations, when you put them all together, you will be able to find the currents I1, I2, I3. And tell me what will be the current flowing through this 200 milliohm? What will be the current in this direction?
I3 minus I1.
Yes, it will be I3 minus I1. Yes. So when you find the all the mesh currents I1, I2, I3, you just have to you can simply find the current flowing through this 200 milliohm resistor by simply doing I3 minus I1. Okay. All
Okay,
right.
sir.
Moving forward to problem 6. Yeah. Again, this is a very easy question. Tell me, find the energy stored by 220 millifarad capacitor. So where is that capacitor? This is here. Tell me, what is the energy stored by this capacitor? How will you do it?
So we'll apply the formula half CV square.
Yes. So what is the voltage? V3 here.
Voltage V3.
Yeah, yeah. So what is that? What is the value of that voltage?
So we have to calculate that using the mesh
Yeah.
equations. And
So first what you can do is simply use transformation, right? This is parallel combination.
okay, sir.
So what will be the effective capacitance here?
30 millifarad.
Yes, 30 millifarad, right? So this will look like a 30 millifarad capacitor here, right? And the voltage across it will be V3, correct?
Okay, sir.
This is 30 milli. And what is 15 and 10 in series? What will it look like?
3 millifarad.
So 5 3s are 15 and
6.
5 5s are 25. Total is 6 milli, right?
Yes, sir.
So this can be replaced by capacitance here, which will be 6 millifarad, right? Now tell me what will be the voltage V3 here?
Sir, can we apply the voltage divider rule similar
Yes,
to the
yes,
resistance?
that is what you have to do here. So what will be the voltage division rule here? What will be V3? So you have a
V3.
circuit. Let me redraw the circuit. Let me please. So this is 30 volts. You have a capacitor here which is 6 millifarad. And you have a capacitor here which is how much? 30 millifarad. And this is the voltage that you are interested in, V3. Tell me what will be the voltage?
So 25 volts.
How did you come up with that?
So 30 multiplied by 30 divided by 30 plus 6.
V3 is equal to 30 multiplied by.
So 30 divided by.
Oh, is it 30 divided by 36 or the other way around?
Sir, it should be 30 divided by 36.
No, it is actually the other way around,
Divided
right?
by
It is 6 milli divided by 30 milli plus 6 milli, right? It's actually slight opposite to what a resistor has, right? Isn't it?
Mm. Sir, I don't remember that.
Okay, so let's
Please forgive me.
solve it. Solve it by okay. Let's do it other way. Hmm? So what will be the okay? If you do not know anything about it, how will you solve it? If you do not remember that formula, how will you solve it? How will you find out
Sir,
what is the voltage?
KVL.
KVL, yes. So what is the KVL here?
Sir,
What will you assume in this? What will be the KVL? Can you assume a current here?
yes, sir.
So how will you assume a current here? In the capacitor, no current flows, right? In a steady state. In DC,
Mm,
this is DC, right?
okay, sir.
It will be charged and no current will flow. So how will you solve it? In this case, you have to assume that there is some charge flow, right? Q.
Okay, sir.
Some charge has flowed in this, which is equal to Q, right? That is what you will have to assume here. So, if, in that assumption, what is the charge distribution? There will be plus Q here, minus Q here. Similarly, there will be plus Q here, minus Q here. Okay.
Okay, sir.
Okay. Now
Sir,
with that, what will be the
sir,
KVL?
solve
Yes.
it is in parallel combination and series combination.
Yeah, you can do that. You can do that. But even then, you will have to find out what will be the voltage here. For that, you will have to use this kind of approach only. Okay. So what will be the now what will be the KVL here? Tell me. So it will be 30. Let's take increments to be negative again. So minus 30 going from here to here, and then
Sir, Q by 6 microfarad.
so it should be plus q by 6 microfarad, right?
Okay, sir.
6 millifarad, by the way, it's not micro, it's milli. 6 milli, yes, and then
Millifarad.
again plus
Then Q by 30
30,
millifarad.
yes, q by 30 millifarad, right? And that should be equal to 0, correct?
Okay, sir.
So this will be how much? This will be q upon 1 over 6 milli plus 1 over 30 milli is equal to how much? 30.
30.
So how much q will be? 30 multiplied by 30 milli into 6 milli divided by 36 milli. How much will that be? So milli and milli cancel each other. 6 6 6 5 so 5 milli. So it will be 150 milli coulomb, right?
Okay,
Coulomb.
sir.
So this much will be the charge stored here. Now tell me what will be V3 in that case. What is V3 again? So you know that Q is equal to
C
150
into V.
millicoulomb, right? So what is V3? C into, or what is C? 30 millifarad, right?
Okay, sir.
Into, or rather V3 is what? Q by C, right?
Okay, sir.
So Q is 150 millicoulomb upon what is C? C is 30
30
millifarad,
millifarad.
right? So milli and milli cancel each other. So it will be how
Yes, sir.
much? 5 volts, right?
Volts. Okay, sir.
So it will be 5 volts. So the same result will come when you use voltage division, which will be V3 is equal to 6, sorry, 30 into by voltage division. So what is the spelling of division, by the way? Is it correct?
I think it is.
Okay, so I also forgot. So let's go with this. So V3 is equal to 30 volts, right? Into 6 millifarad upon 6 milli plus 30 milli. So how much is this? This is 5 volts, right?
Okay, sir.
So in the
Sir,
case of
whenever we
capacitor,
have, sir,
yes,
we are dealing with a DC source, and we
huh?
are given capacitors in the circuit. We have to assume that it is a steady state condition.
Yes, there can be no other condition. If this is a DC source, then it is a steady state condition, because if it would have been a voltage source and a unit step would have been given here, then it's not a steady state, right?
Okay, sir.
But in this case, it has assumed that this is a DC of 30 volts. It's always 30 volts. It has never started. It has from from since Big Bang, since the Great Big Bang, it has been 30 volts only. Okay. So
Okay,
since the
sir.
universe started, it is 30 volts only. It has not started, it is not ending. It's always 30 volts. So it is always steady state, DC steady state. Okay.
Okay, sir.
Yeah, fine. So this is easy. Anyone having any doubt in this question? All right. So correct. So this is V3. V3 is simply 5 volts we obtained. Okay. Let's move forward to problem number 7. Okay. Yeah. Uh, yes. Find V of t for t is equal to 3.5 and t is equal to 5 seconds. You see, this is an inductor. Okay. So this is an inductor here, and in this inductor, you are told to find out what is V of t. Okay. At what times? T is equal to 3.5 seconds and 5 seconds. So 3.5 will be somewhere here, right? 3.5 seconds, and 5 seconds will be somewhere here. Oh, not right. So let's call this as let's take, this will be 4, this will be 5. So 3.5 will be somewhere here, right? This will be 3.5 and this will be 5, right? Similarly 2, and let's call this 3, and 4, and this is 5. So this is 3.5, this is 5. Yeah, so you're told to find out what is the voltage v of t at 3.5 seconds and 5 seconds. So how will I solve this?
KCL,
Huh?
sir, KCL.
Yes, so KCL at what, where?
There is only one node, sir.
Yes, correct. There is only one node, so no ambiguity there. So you have to find out what is the current entering here, right? Well, let's do this. V of t is this one, right? Let's follow passive sign convention here. So current, let's assume this to be the positive current. Let's call it IL of t. L means inductor, okay?
Okay,
So
sir.
let's call this current ILT. So this will be IL of t. So tell me, what will the equation look like here at this node? What will the KCL equation look like?
Sir,
I get
ILT plus I2T is equal to I1T.
ILT plus I2 of t is equal to I1 of t.
I1T.
Anyone having any doubt in this equation?
no, sir.
Yeah, fine. KCL at the only node. Okay, fine. This is done. So, okay. So, what will be IL in that case?
I1 minus I2.
I1 of t minus I2 of
I2 of
t.
T.
Right. And what is the voltage across an inductor? What is V of t? What is V of
LDI
t?
by dt.
V of t is L times d
D
IL of t by
by
dt, right?
dt. Yes.
So what will that be? L times d of I1 of t
I2T.
minus I2 of t by dt, which will be what? L times di1 by dt minus sorry, L times di2 by dt, right?
Okay, sir.
Yeah. So now tell me, what will it be? So what is the slope at this? So what is di1 by dt at this point of time? 3.5 seconds. What is di1 by dt at 3.5 seconds?
So -1.
Minus 1, did you say?
Yes, sir.
How did you find it out?
Sir, it is decreasing, sir. The change in y is negative
Correct. It is
divided by the
decreasing.
change
Yes, it is decreasing. So basically you have to find the slope at this point, right?
del x by del z.
Del
Del x
z
by
by
del y.
del x, right? So you have to find sorry, you have to find the slope, right? Slope at this point. Slope is what? y2 minus y1 divided by x2 minus
x2 minus
x1.
x1.
So tell me what is, so let's choose a point, right? So since it is a straight line, its slope is constant from this point till this point, right?
Yes, sir.
So what is, let's select any 2 points here. So let's select these 2 points only, 6 and 3, right? So what will the
Yes.
slope here? What is y at 6?
0.
0. Minus y at 3, it is 3,
3.
correct? What is the
Okay,
x
sir.
at 6? It is 6 minus
6,
3, right?
3.
So it is minus 1, correct. So what is minus 1? What is the unit here?
Uh-huh.
What is the unit here?
One is
amps per second.
Yes. Always pay attention to units, okay? Always make it a habit to pay attention to the units. This way you'll make lesser number of mistakes. Okay, so this is fine. Similarly, at 5 seconds also, this is the same slope, right? 5 seconds also the slope is same, right? Am I right?
Yes, sir. Yes, sir.
Yeah. The slope at 3.5 and 5 seconds, right? Okay, now tell me what will be the slope at 3.5 seconds for this particular I2t. What will be di2 by dt at 3.5 seconds?
0.
0.
0, correct. So di2 by dt at 3.5 seconds go to 0. Fine. Now what is di2 by dt at 5 seconds?
Sir, -2.
Again the same thing, right?
Minus
Select
2
these 2
ampere per
points,
second.
then again this will be what? y2 minus y1 divided by x2 minus x1. This is the slope at 5 seconds. It will be y2 will be 0 minus 0 minus
4,
y1 will be how much? This is 4 divided by y2 is x2 is 6 minus 4.
2.
So it is minus 4 by 2 is minus 2. How much? Amperes per second, right?
Yes, sir.
Right. So now we have everything that we need, right? So tell me at t is equal to 3.5 seconds. What is v of t? What is it? L is how much?
2 Henry.
2 Henry, right? So 2 Henry multiplied by di1 by dt is what? Minus 1, right?
Okay,
Minus 1. Minus what is di2 by dt at this point time? 3.5 seconds. It is 0. So it will be how much? Minus 2 volts, right?
okay, sir.
Again, what is v of t at 5 seconds? 2 multiplied by again minus 1 minus 2,
Minus
right?
2.
Okay, sir.
So how much will it be?
Sir, plus 2 volt.
Yes. Is it fine?
Yes, sir.
Yeah. So this is how you calculate. So this is nothing special about it. Yeah, this is the last question probably that I will discuss today because it is already 2 hours and we have been solving questions non-stop. So I am sure you would have exhausted, right? Till now. You would have been bored by now, right? Alright, so anyway, so this question is the last one that I will be solving today. There are 2 other questions also, but that I want you to solve on your own. So these 2 I want you to solve on your own. Ask me if you have any doubt in the next session. Alright, so this is square wave generator produces the voltage waveform shown in the figure below. Okay, this is the square wave generator response. So as the name suggests, it generates a square wave. So you see this is a square wave, right? This is a square wave. This is the voltage waveform that it will generate. Now, what kind of a circuit component is needed to convert the voltage waveform to the triangular current waveform shown in the figure below? Yeah. So tell me, given that you have a voltage waveform like this, how can you generate a voltage waveform in this of this kind using some circuit components? So let me rephrase the question. This is a voltage waveform. Let's call it a voltage source here. Let's call it. This is a voltage wave. This is a voltage generator which generates a voltage V of t, which is shown here. Okay, V of t is shown here. Now, how will you generate a voltage of this kind? You can connect anything here. Okay, but at the output, what do you want? You want a voltage of this kind. Oh
Sir,
no,
using
sorry.
an
You
inductor.
want to convert this voltage into current waveform. Actually, you want a current at the output. So how will you generate it? So, okay, so
Sir,
let's do
using an
this.
inductor.
I1 of t has to be of this kind. Okay, so you're saying using an inductor. You're saying you have to use an inductor. Okay, let's
Yes, sir.
see whether that helps or not. So what is the inductor equation? What is the voltage across an inductor?
V equal to LdI by dt.
Di by dt, right? So what is the current? I of t is equal to what? Is the integral, right? Am I right? Is this fine?
Yes, sir.
Hmm. So let's assume this I of 0 is 0 for a moment. So it will be I of t will be what? 0 to t 1 over L V of t dt, right? Correct? So the current is
Yes, sir.
basically, the current flowing in an inductor is basically the integral of the voltage that is appearing across an inductor, right? Correct? So if this is an inductor here, then the current which is going to flow through it, I of t, is basically an integral of the voltage that is appearing across it, right? Fine. So please tell me, please now see this. So this is a square waveform here. So what is the relation between the square here and the triangular waveform here? What is the relationship? It is that of an integral, right? If you integrate this square, you are going to get this this particular triangular waveform, isn't it? You see, in this time from here to here, in this region, when you integrate it, you will simply be creating a ramp function, right? Is everyone with me here? What is the integral till here to here, from this point to this point? This is v of t. V of t is 5 times nothing, right? Dt, correct?
Yes, sir.
Yeah, so it will be simply 5t dt, right? 5
Yes, sir.
into t and nothing else, 5 into t. So that is the equation of a straight line, right? I
Yes,
of
sir.
t will be 5t. It is a straight line. It will be of this kind only, correct?
Okay, sir.
So the relationship between a square of this kind and this triangular waveform is that of an integration, correct? Is everyone following
Okay.
this?
Yes, sir.
Yeah. So that is why you see, basically this is this triangular waveform is basically an integral of this voltage waveform here. See, from here to here you will be increasing the triangular waveform. This triangle will be increasing, right? The slope will be positive, but here suddenly the voltage has become negative here, so the current will start to decrease, isn't it?
Okay, sir.
Again, when the voltage becomes positive here, it will again start ramping up, and the same
Okay,
thing
sir.
will go on and on forever. Okay, so basically you want to, if you want to convert, if you want to generate a current waveform of this kind from a voltage waveform of this kind, you have to be able to integrate this voltage, right? And the current should
Okay,
be
sir.
actually proportional. The current that you want to get at the output should be proportional to the voltage, not just the voltage but the integral of the voltage, right? That is how you will be getting it. Are you able to understand me?
Sir, your last line, please
Yeah, so
explain.
okay, I'll explain that again. You do you understood this, right? That the current waveform here is actually proportional to the integral of the voltage, right?
Okay,
It is
sir.
not proportional to the voltage but the integral of the voltage. You understood?
Okay, sir.
It is proportional to the integral of the voltage, correct? This is understood that it is somehow the current and voltage waveform here, the current here and voltage waveform here, they are not just related by a proportionality constant. There has to be an integral in between, right? Integration operation has to happen in between, right? Only then can you get a current waveform of this kind from a voltage waveform of this kind, right?
Okay, sir.
So what I'm saying is, so in order to get, if your final objective is to get a current waveform of this kind from a voltage waveform of this kind, there has to be an integral, there has to be an integration, right? You have to integrate the voltage, and only then you can get a current like this. So what I'm saying is that, in other words, I of t has to be proportional to the integral of the voltage, right?
Okay, sir.
Is that fine now? You understood?
Yes. Okay,
Yes,
sir.
sir.
Yeah. So it cannot be directly proportional to voltage, right? Because directly proportional means when voltage is zero, current is zero. Voltage is basically, if the voltage had been if the current had been directly proportional to voltage, the how would have been the current waveform? Tell me.
It
So the
will also
same
become
square
a
wave but
square wave.
different amplitude.
Correct. It will be like this only, right? It will be in this manner only, right?
Okay, sir.
But this is not what we want. We want a triangular waveform. So it should be proportional to the integral, right?
Okay, sir.
Correct? Okay. Now, when we know that the current has to be proportional to the integral of the voltage, there is only one possibility, right? There is only one element which has current proportional to the integral of voltage, right? That is an inductor, correct?
Okay, sir.
So basically, this has to be an inductor like this. And what will be the value of that inductor? Tell me. Can you find out what will be the value of inductor?
Sir, when V is 5, then di by dt is 4 by 1 ampere by
When V is
millisecond.
5, then di by dt is what? 4 by 1. It's actually 4,
4
right?
by 1, yes, sir.
4
Ampere
how
by
much?
milliseconds.
4 ampere by
Ampere by
millisecond.
milliseconds.
Yes. So it will be 4,000. Oh, sorry. 4,000 ampere per second, right?
Yes, so now L can be found out by V equal to L di by dt.
Yes, correct. So L can be found out by V is equal to L times di by dt. So what will it be? V is how much? 5 volts. So that is equal to L times di by dt, which is 4,000, right? So what is L? 5 by 4 10 to the power minus 3. How much is this? 1.25. Am I right?
Yes, sir.
1.25, right? Milli Henry. So is this clear to everyone?
Sir,
Yeah.
I have a different approach, sir. If
Haha.
IT
What?
and integral of VT dt are proportional, then
Yeah. Yes.
dividing IT by integral VT dt at some chosen point will
Huh?
give the proportionality constant.
Yes.
So
Yes.
I
Yes.
will choose a point of time equal to 1 millisecond.
Okay.
Their their IT is 4,
4.
and
Yes.
the VT is 5.
B of t is 5. Yes.
Sir, can we divide them both? It will also give 1.25.
Okay. Let's do this.
Is it okay, sir?
No, no. 1 second. Let's find out, na. Is it okay or not? So let's find out. So I of t is equal to 1 over L integral 0 to t uh, v of t dt, right? Fine. So you are saying that L is equal to simply integral 0 to t v of t dt upon I of t, right?
Okay, sir.
Fine. So you are saying that
Yes,
why not calculate it at some t is equal to 1 millisecond, right? That
yes,
is
sir.
what you are saying. So, okay, you can do that. L is equal to 0 to 1 millisecond v of t dt upon I of t at 1 millisecond is 4, right? 4 amperes. So again, you have to find out what is v of t into dt from 0 to 1 millisecond, that you have to find. Basically, what will that be? Area under this curve, right?
Okay,
Integral
sir.
of this from 0 to 1 millisecond will be simply the area under this curve. Okay, so let's erase everything which is not necessary here. Okay, what will be integral of this from 0 to 1 millisecond? Integral of this from
Sir,
0 to 1 millisecond? It will
5.
be area under this curve, correct?
Yes, sir.
Yeah, so what will it be?
5 multiplied by 1.
And what will be the unit of that?
Sir, 0 to 1 second, sir, limit.
1 millisecond.
Sir, yes, sir, millisecond.
Yeah, so
Sir,
what will it be?
sir, integration is interpreted as the area under the curve. So, sir,
Yeah,
area under the square wave is simply the length multiplied by breadth.
yes,
Sir,
so it will be 5.
yes, sir,
Area is simply
5 units.
5, how much? Milli, right?
Volt second, sir.
Volt into seconds, yes. That's what it is. 5 millivolt seconds. So it will be how much? 5,
5.
oh, sorry, 5 millivolt seconds divided by 4 amperes, right?
Yes, sir.
So it is 5 milli, or let's move this units here. So 5 milli by 4 is 1.25 milli Henry, right?
Okay, sir.
You are getting the same answer, correct?
Yes, sir. Sir, is this approach okay?
Yeah, it's fine, it's fine. Any way you do, it's fine. As long as you're clear on the concepts, it's fine. Okay, so there's no doubt in this question, right? You understood the idea basically here. Sometimes you will have to, you will need this kind of logic here. So the logic that I explained here should be clear to you. You wanted to convert a square waveform voltage into a current of triangular waveform, right? So you must have so the reasoning behind this should be clear. Is that fine?
Yes, sir.
Yeah. So when you go further, when you will learn the next level of this course is analog IC design. Okay, again taken by Professor Nagendra Krishnapura. So in that in that course, you'll come across an element called gyrator. Okay, or maybe even higher when you go, you'll come across an element called gyrator. So gyrator is nothing but something which converts uh, which converts a capacitor into an inductor. It's an element, it's a network. Okay, a gyrator is nothing but a gyrator is nothing but a network which converts a capacitor here. When you look from here, the current relationship and voltage, the current to voltage relationship, looking from this side of the network, it will look like it is an inductor. Okay, you're getting what I'm trying to say? From this side when you look, it will feel like an inductor, but here it is a capacitor, and you will not place any inductor in this network. Okay, this is
Okay,
some
sir.
network. You will not place an inductor here, but you will place some elements here which will make us believe that the capacitor here, it's looking like an inductor when seen from this side. Okay, and there the logic that we'll be using will be very similar to this. I mean, the reasoning will be, this kind of reasoning will be very helpful in that case. You want to convert some kind of waveform into another kind of waveform, what kind of elements you require. Okay, this kind of reasoning is very important. Fine.
Okay, sir.
Yeah, so I guess that concludes today's discussion. Okay, so we'll again be meeting on next Saturday. Okay, thank you everyone for joining. So that's all. Let's meet again next Saturday.
Okay, sir. Thank you, sir.
Yeah, welcome.